If you accidentally swallow a mouthful of ocean water while swimming at the beach, your body immediately panics, your throat stings, and you are left wondering why 70% of our planet is covered in liquid we literally cannot drink. If Earth is supposed to be the ocean planet, why did nature turn almost all of our water into a giant, undrinkable broth? The answer sounds like a complete natural contradiction, because the main thing making the sea so salty is actually the fresh water running right through your town. Think about how bizarre that is for a moment. Trillions of gallons of fresh water rush out of mountain streams every day, snake across continents, and pour straight into the sea. If you dip a cup into the Mississippi River or the Amazon River, it tastes completely fresh. So if fresh water is constantly pouring into the ocean, shouldn't the ocean be getting diluted? Shouldn't it taste less salty every single day? Instead, the exact opposite is true. Rivers are actually the primary delivery trucks bringing salt into the sea in the first place. Every single second, the rivers of the world carry about 4 billion tons of dissolved minerals straight into the ocean. To understand how a crystal clear mountain stream turns into a salt delivery service, we have to look at what happens every time it rains. It all starts high up in the atmosphere. Rain isn't just pure water. As water vapor condenses into clouds, it mixes with carbon dioxide in the air. This chemical reaction forms a very weak acid called carbonic acid. Now, don't worry, this isn't toxic acid rain that melts your car hood. It is extremely mild, about the same acidity as a can of sparkling water that was left open on your counter for 3 days. But to a solid rock, even mild acid is a slow, relentless chisel. When this slightly acidic rain falls onto the land, it lands on granite, limestone, soil, and mountain ranges. Over thousands and millions of years, this acid slowly breaks down the rock through a process called chemical weathering. Rocks are packed with minerals that contain different elements, including potassium, calcium, magnesium, and most importantly, sodium and chloride. When combined, sodium and chloride form sodium chloride, which is the exact chemical name for the table salt you sprinkle on your fries. As the rain breaks down the rock, these minerals split apart into tiny invisible particles called dissolved ions. The rainwater washes these ions into local streams. Those streams merge into roaring rivers, and those rivers carry that invisible cargo on a one-way trip straight to the coast. So why don't rivers taste salty to us? Because rivers are always moving. The concentration of salt in river water is super low, so low that your tongue cannot detect it at all. River water is continuously flowing out to sea and getting replaced by fresh rainfall. But once those dissolved minerals reach the ocean, they run into a massive geological trap. Water can leave the ocean, but salt cannot. When the sun beats down on the ocean, it heats up the surface water. Water molecules evaporate into the sky to form new clouds, but they leave every single particle of salt behind. The salt molecules stay in the ocean, trapped forever. That evaporated water then turns into fresh clouds, travels back over the land, falls as fresh rain, breaks down more rocks, picks up more salt, and carries it right back to the sea. It is a planetary loop that has been running continuously for over 4 billion years. To really understand how much salt has built up because of this process, let's play a quick, mind-bending mind game. Imagine we could somehow suck all the water out of every ocean on Earth, take all the remaining salt, dry it off, and spread it evenly across all the dry land on the entire planet. Do you know how thick that layer of salt would be? It would cover every single square inch of land on Earth, every city, forest, desert, and mountain, under a solid blanket of salt 500 feet thick. That is roughly the height of a 40-story building, made entirely of solid salt, covering the entire planet from coast to coast. Now, if you think land rocks are doing all the heavy lifting, get ready for an unexpected twist. Rocks on land account for a massive chunk of the ocean's salt. But the deep seabed has its own secret salt factories running 24 hours a day, 7 days a week. Deep beneath the surface, where Earth's tectonic plates pull apart, seawater leaks down through deep cracks in the ocean floor. As this water trickles miles down into the Earth's crust, it gets squeezed right up against white-hot magma from the Earth's mantle. The water gets heated up to insane temperatures, sometimes exceeding 700 degrees Fahrenheit, or about 370 degrees Celsius. Because of the crushing pressure at the bottom of the sea, the water cannot boil into steam. Instead, this superheated water acts like a hyper-aggressive chemical solvent, dissolving minerals directly out of the deep crust rocks underneath the seabed. Eventually, this mineral-rich fluid blasts back up into the cold ocean water through towering underwater chimneys known as hydrothermal vents. These vents spew out massive black plumes of dissolved minerals every single second, adding millions of tons of extra salt directly into the deep sea. On top of that, underwater volcanoes periodically erupt along oceanic ridges, baking minerals directly into the surrounding water. At this point, a very logical question should be popping into your head. If land rocks are constantly leaking salt, and underwater volcanoes are constantly pumping salt, why isn't the ocean getting saltier every single year? Why hasn't the sea turned into a solid, slushy block of salt paste by now? This is where Earth pulls off one of its absolute best natural balancing acts. The ocean actually reached a state of chemical equilibrium about 1.5 billion years ago. The sea is about 3.5% salt by weight, meaning in every 1,000 grams of ocean water, about 35 grams are dissolved salts. And that concentration has stayed remarkably stable for hundreds of millions of years. How is that possible? Because just as fast as salt enters the ocean, nature finds ingenious ways to remove it. Marine organisms like clams, oysters, corals, and trillions of tiny plankton constantly extract massive amounts of dissolved calcium and silica out of the water to build their hard shells and skeletons. When those creatures die, their shells sink to the deep sea ocean floor, locking those minerals into thick sediment beds that eventually compress back into solid rock over geological time. Additionally, sodium ions react with clays on the ocean floor and get reabsorbed into the crust, while huge amounts of salt get blown back onto land by ocean winds in the form of coastal sea spray. The Earth essentially maintains a perfect thermostat for salt. Salt in equals salt out. Unless, of course, a body of water loses its exit door. When a lake or inland sea has rivers flowing in, but no river flowing out, Earth's balancing system completely breaks down. Take the Dead Sea, located between Jordan and Israel. It gets fed by the Jordan River, carrying minerals down from the surrounding land. But the Dead Sea has no outlet to any ocean. The only way water can leave is by evaporating under the scorching desert sun. Because of this, the salt gets left behind and builds up to absurd levels. The Dead Sea isn't 3.5% salt like the ocean. It has a salinity of roughly 34%. That is nearly 10 times saltier than the ocean. It is so dense with dissolved salt that you cannot even sink in it. Human bodies float on top of the water like plastic corks without even kicking their legs. If a fish from the Jordan River accidentally swims into the Dead Sea, it dies almost instantly from dehydration, as the salty water sucks moisture straight out of its cells. The same exact thing happened to the Great Salt Lake in Utah, where salinity can reach up to 27% in certain sections, depending on local rain levels. These extreme, hypersaline lakes show us what the entire ocean would look like if Earth's natural sediment recycling system ever stopped working. So the next time you are standing at the edge of the beach, watching the crashing waves, or wincing from an accidental gulp of ocean spray, remember what you are actually looking at. You aren't just looking at water. You are staring at a 4.5 billion year old global recycling program. Every wave holds the dissolved history of ancient mountain ranges, carried down by rain, cooked by deep-sea volcanic vents, and kept in perfect harmony by billions of shell-building creatures under the sea. Before you head off, I have a quick question for you. Have you ever swam in a body of water so salty that you floated effortlessly, like the Great Salt Lake or the Dead Sea? And what did that feel like? Tell me your story in the comments below. If you found this video fun and learned something new, click that like button, share it with a friend who loves weird science facts, and subscribe so you never miss another deep dive into how our incredible planet works.